everybody, and thank you for joining me for another episode of Math with Sohn. Today, we're going to be finding the volume and surface area of a sphere and half of a sphere. Let's get into it. So finding the volume or surface area of a sphere is as simple as just following a formula. So the volume formula is 4/3 pi r cubed, and the surface area formula is 4 pi r squared. And we're going to be finding the volume and surface area of this attempt of me drawing a sphere. So the volume is going to be 4/3 pi r, the radius is 4, cubed. Order of operations dictates that we're going to have to do 4 to the third power first, which is 4 times another 4. And if you multiplied 4 times a third 4, you would end up with 64. Now what I'm going to do from this part is I'm going to multiply the 4 on right here times the pi times the 64, and I'm going to divide by 3 last. It just seems easier for me to do that this way. So I'm going to do 4 times pi, I'm going to turn that into 3.14, times 64. I'm going to multiply those three things together, and then I'm going to divide by 3. 4 times pi times 64. I get 803.84. And then I'm going to divide by the 3, which is this 3 right here. That's all divided by 3. So after I've done multiplying it, then I divide by 3. So I'm going to hit divided by 3, and I get my answer. I get volume is equal to 267.94. Rounding up 0.95 inches cubed. Alright, surface area, it's an even easier formula. It's 4 pi r squared, so we're just going to use the formula, and we're going to plug in 4 for the radius. So surface area would equal 4 pi times the radius is 4, squared. And if we follow our order operations there, we have to do 4 squared first, which is 16, times the 4 pi. So I'm going to do 4 times 3.14 times 16. 4 times 3.14 times 16, and I get 200.96. And that's it. That's all she wrote. That's the surface area. Alright, so the surface area of a regular sphere and the volume of a regular sphere, just follow the formula as is. So for the volume and surface area of our next example, we're going to have not a full sphere, but a hemisphere, which is half of a sphere. And finding the volume is going to be pretty much the same way, but if you're finding the volume of half a sphere, when you're finished with finding the volume of the whole thing, you just divide it in half. So we're going to start with our volume, and we're going to find the volume as if it was an entire sphere. So I'm going to use my 4/3 pi r cubed, and my radius is 5. Now because this is a sphere, this 5 could have been anywhere. It could be from left to the right, up and down, any direction. It's still going from the center to the side. It is still considered the radius of that sphere. So we're going to do 5 to the third power. 5 to the third power is 5 times 5 times 5, which is 125. Pi, I'm turning into 3.14. 5 to the third power is 125. For this part, I'm going to again multiply by 4 first. So I'm going to do 4 times 3.14 times 125. And then divide by 3 when I'm done with that. So 4 times 3.14 times 125, I get, surprisingly, a whole number, 1570, and then I divide by 3. And I get, for my answer here, 523.3 repeat. Now, we're not done. That would be the volume of the entire sphere, but this is not an entire sphere. This is half of a sphere. So I have to take this number and I have to divide by 2 because we're not finding the volume of an entire sphere, we're finding the volume of half of it. Notice how I did not round this number early. You'd want to keep that in your calculator and then divide by 2 with it still in your calculator. That way, if you round early, you're not going to get an answer that's going to be further away from the truth. You only want to round at the very last step. And in this case, we get 261.6 repeats. So at this point, it depends on how you would like to round. I would like to round to the nearest tenth, so this is really 6, 6, 6, 6, 6, 6, 6 forever. And that would be rounding to 261.7 if I round to the nearest tenth at the very end, inches cubed. And that would be the volume of half of the sphere. So let's find the surface area. Now, the surface area is going to be similar to how we found volume, where we're going to find the surface area of the entire sphere and then cut it in half. But there's going to be an extra element that will be needed to be addressed as well. Because you're not just finding the surface area of what's on the outside anymore. If you cut it in half, now you also have this circle right here that also is an outside surface that we would have to add to the surface area. So it's not just taking the outside wrapping of the circle that we're cutting in half. We are doing that, but we're adding an additional surface now. We're adding this circle that's on the top layer to the surface that wasn't there even at all before. So we're going to start again with as if we were finding the surface area of the entire shape, which would be just 4 pi, the radius is 5, squared. So that would be 4 times 3.14 times 25. 4 times 3.14 times 25 is 314. That would be the surface area of an entire sphere, but we again don't have an entire sphere, we have half of one, so we have to divide that by 2, and when I divide that by 2, I get 157. Now, that is just half of the outside area, so that would be this part right here on the outside that I'm kind of highlighting right now, all the way wrapping around this sphere. But we still now have created this cut surface of the circle on top, so now I have to add in that circle, and this would just be the outside sphere-like stuff, technically half of the outside sphere stuff. We still have to add the area of that surface of the circle, which is an area of a circle problem, pi r squared. Pi r squared is the area of a circle. So we have to do another plus pi r squared. Well, we're going to have 157 plus pi times 5 squared. So 157 plus 3.14 times 25. Because r squared would be 25 from the 5 squared. And we get final answer 235.5 inches squared. So, the surface area formula for a semisphere, or hemisphere, like just half of it, would be equal to 4 pi r squared divided by 2. That gives you the half of the outside envelope of a sphere. And then you have to add in that circle on the top, which would be plus pi r squared. So for those of you looking for a formula that works for half of a sphere for a semi-circle or a half a circle, which is really a sphere, for half of that sphere, you would use that formula. All right? That's going to do it for today. It's a little bit short, but spheres are pretty simple. Hope everybody's well, and see you later. Bye.